We've mentioned it a few times. Let's actually get into this. Let's talk about deep visibility. Deep visibility is one of the main functions that we have in our platform. It can be seen in most of the 6 steps. Identification, containment, eradication, and recovery all use some portion of the deep visibility package. And we're going to go through an overview in this presentation to give you an idea of where we can see it and what we can do. We'll go into more specifics in further presentations. In the identification phase, we're all about finding previously unknown malware. Deep visibility constantly gathers information and sends it up to the centralized server. There we can go through and search that for anything we want to try to find. When we're talking about identification, we're talking about finding the malware that exists on our systems that doesn't get automatically flagged with our AI systems. So we're looking for anything that is new, unique, and for some reason cannot be found with the AI. This gives us the opportunity to search for all of that new and exciting types of malware. On the containment side, containment is still pretty small, but when we actually are finding the malware ourselves, we have to be able to mark it as either malicious or suspicious. So using the deep visibility and storylines, we can mark entire storylines as either suspicious or malicious. Eradication, we use it a lot. The eradication phase is all about trying to find all of the artifacts that got changed, all of the things that the malware did to our systems, and of course, having an understanding of every event that took place and what happened, and being able to go through and search for each of them allows us to figure out exactly how far the malware got to go on our individual systems. We can find all the artifacts that took place and that got added or changed. And usually we can trace the systems back to the original impetus of the problem to discover the root cause. Without finding the root cause, we're not going to be able to understand what the attackers originally did to get onto our networks. This is an incredibly important function of deep visibility. On the recovery side, remember there are 2 functions of recovery. The first function is to put the systems back online, of course, and deep visibility, or in this case, the storyline that relies on deep visibility, was one of the reasons we were able to go through and recover the system during the eradication phase. Now the system is ready to be placed back online, we have to be ready to watch for the return of the attacker. One of the biggest tools we have in our arsenal for that is STAR, which stands for Storyline Automated Response. And in order to create a STAR rule, you need to understand how deep visibility works. Deep visibility is the basis upon which STAR rules are created. And if you wish to actually fully utilize the functionality of STAR, you'll need to have a very good understanding of deep visibility. The process is actually not too complex, but the ramifications are deep. Each agent watches for events on the system that it's installed on. Each event generates a record, and each record is first cached locally on the machine and eventually sent up to the console, where it is stored in a data lake with all the other events from all the other machines. Deep visibility itself does not make any determination about whether the events are benign, malicious, suspicious, or anything. It doesn't know. It doesn't care. It's simply gathering the information and sending it to a centralized location and leaving the decisions on what it means up to the analyst. Deep visibility allows us to look backwards in time. Obviously, these events that are being sent up to the centralized server, we're allowed to search through them. And there is a time limit for how long these events stay in the data lake. By default, all events will stay in the data lake for 14 days. If you wish to have more time or keep the events for a longer period of time, you can buy additional packages that add anywhere from 30 to 365 days. If you have a full year's worth of information, that does mean you can go all the way back for 365 days with all of the data that Deep Visibility collects and look for various activities inside your network. This can be enormously helpful if you don't know when an attack occurred, or you don't know when exactly an attack managed to get into your network. What if the attacker got in and then laid low for 3 to 6 months? That's actually a common tactic. That way the attacker does not give away how they got in, because they assume you're not collecting data long enough to be able to tell what happened. They're assuming that the data has been lost. In this case, it would not have been. Here's a listing of all of the events that our agent searches for or waits to see happen. We're not going to go through all of these in great detail. I do want to mention that they're all here and that we can group them into functional groups. Upper left-hand side, you see process stuff, creation of processes, modification, the handles, threads, terminations. We have networking things, connections. We have the creation, modification, scanning, and deletion of files. We have DNS, registry stuff. We have the registration and the update, the trigger, and the deletion of scheduled events on our system. Who logged in, when we go out to the website, and so on and so forth. All of these are events that take place. Whenever one of these events take place, we actually get to see an object created. Different objects are created for different events. This is the listing of the 12 events, This is the listing of the 12 objects that we can create. Processes, network actions, files, detections, logins, URLs, DNS, scheduled tasks, registry, modules, indicators, and command scripts. Each one of these is a unique data object because the event that took place was of this kind of function. Just so you can see it, here are the events and the data objects on one slide. We're not going to go into this eye chart in depth. This is more for your reference. So when you look at this later, you can say, oh yes, I understand that, for example, under files, there's the creation, modification, scanning, deletion, and renaming of files. If any of those events took place, a file type object is created. Same goes through for URLs or scheduled tasks. Anytime a scheduled task is registered, updated, started, triggered, deleted, we all have, it'll create an event, and that event will create the object scheduled task. This is a good place to stop for now. In the next video, we will talk about the data we actually gather for each of the objects that we see on this screen and the events that go with it.